Hello Year 9, hope you're all doing well during the lockdown and all staying healthy. This is our last lesson in the Forces 1 unit and it's called Friction and Stopping Investigation. And we have lots of objectives this time. First one, I can recognise ways to increase and decrease friction. Second, I can describe the energy transfer when friction stops a car. Third, I can recognise the relationship between friction and braking distance. And the last one, I can explain the consequences of large decelerations. So look at the park over on Eggford Lane. Lots and lots of fun here. I'm sure you've been here before. And I want you to open up your book and jot down some bullet points and write down where you would experience friction here. So pause the video and jot down some ideas, please. Okay, let's have a look at some ideas that I've thought of. Perhaps you've thought of the same ones. Maybe you thought of different ones. Let's have a look. So the first one I thought of was the swing. So there's friction between you when you sit down on the swing, so between you and the swing. There's also friction between you and the air particles as you swing on the swing. The second one I thought of was perhaps your feet and the stepping columns. So I thought perhaps there might be some friction there. The third is over on the climbing wall. So there's friction between your hands and the climbing wall when you touch them or when you pull yourself up. And the last one is over on the slide. There's friction between you and the slide itself when you slide down the slide. Perhaps you thought of lots of others, so well done if you did. So looking at the slide then, this can actually help us to determine what friction is. So friction is a force that occurs between two surfaces that are sliding or trying to slide across one another. For example, when you slide down the slide, friction makes this difficult. Okay, it's trying to stop you from going downwards. It works in the opposite direction, and we learned about this in a previous lesson. So friction is an oppositional force because it works in the opposite direction to which the object is moving. So can you please pause the video and write down the words on the left into your books, please? All right, let's carry on. So here's a skier going to the left. You can see the pushing force from them is going to the left, and friction force in this case is parallel, but it is in the opposite direction. And as again, it's because friction is an oppositional force. But you probably know this, I'm sure you do. You rub your hands together. Okay, so you have friction there between the two surfaces, one from one hand, one from the other, and you rub them together and it generates a lot of thermal energy. So it's one way of keeping warm. But I wonder if you can think of any other examples where friction generates thermal energy. So can you pause the video and then jot down a couple of ideas where friction generates thermal energy? Okay, let's have a look at some of the examples that I've thought of. Perhaps you thought of the same ones. So the first one I thought of was a match striking across a striker. Friction there between the striker and the match, and you can see the thermal energy being transferred there. Perhaps you thought about a tyre wheel spinning on the road, or perhaps one of those bushcraft tasks where they spin the wood on another piece of wood, and you can see the smoke being generated there. Or perhaps you thought a meteorite. There's lots of friction between the meteorite and the Earth's atmosphere, and it actually heats the meteorite and breaks it up. Stops it from hitting the Earth and causing worldwide damage. So we're very thankful to have an atmosphere. Another example of a bushcraft there where you have your hands spinning the wooden rod. So there's friction between your hands and the rod, and your hands will warm up, as well as friction between the wooden rod and the wood at the bottom. And then the last example goes back to a car again. If you spin a wheel really, really fast and then you apply the brakes very, very hard, you can see that the brake discs there are glowing very, very hot. And below here, there's a YouTube video that shows just that. So if you like to stop the video, type that into YouTube, or you can go straight to the PowerPoint and click on it directly, and then you can just watch. It's a very short clip, but it's very interesting to see the thermal energy being transferred there. So if you've watched the video or not, it doesn't matter. You can see that the brake discs are getting very, very hot there. So what exactly is going on? We need to be able to explain scientifically why that thermal energy is there in the first place. Okay, so when a force is applied to the brakes of the vehicle, work done by the friction force between the brakes and the wheel reduces the kinetic energy of the vehicle, and so the temperature of those brakes increases. The greater the braking force, the greater the deceleration, and the greater the temperature of the brakes. What I'd like you to do is to reread the words above, add a diagram to it, and reword that, because they're my words, that's how I would explain it, but you need to write it in a way that makes sense to you. And the important keywords here to use are force, work done, friction, and kinetic energy. And they're words that you've met this unit or you've met in the Energy 1 unit. So I want you to reword the words above, add a diagram to help you, and make sure you use the coloured words at the bottom in your answers. So if you pause the video now and have a go at that activity, please. Okay, let's move on. So last lesson then we looked at different factors that affected the thinking distance and the braking distance, and how that had an overall effect on the stopping distance. So if the road is icy, a vehicle tries to stop. What happens? So there's a nice video that you can watch here on YouTube. Again, you can just type that straight into your Google bar, or you can open up the PowerPoint and just click it directly. And what happens is that the road is so icy that the buses and the cars are unable to stop, and they slide into each other. So when the road is icy, the braking distance is going to increase, and when you press the brakes, there's very little friction between the wheels and the icy road. So the car or the bus just slides onwards. So questions here for you. So number one, why is the braking distance further on an icy road? And this is worth 4 marks. So think about what you've just written down on the last slide, and think about what you learned about last lesson and try to connect the two ideas together. And in question 2, why does the bus have a much larger braking distance than the car? And this one's worth 3 marks. So if you pause the video and have a go at answering those questions, and then we'll go through the answers in just a moment. Okay, let's look at some answers then. So for the first one then, well, there's less work being done between the tyres and the road, so friction is reduced. It takes a longer time to reduce the kinetic energy, and the vehicle continues to move onwards and onwards during this time. Number 2, the bus has a much larger mass, so more work needs to be done to reduce its kinetic energy. If you didn't get those answers, just write them underneath your answers now in a different colour so that you're able to learn from that at a future date. Okay, so now we're back and through. Let's calculate the braking force for the bus and the braking force for the car. So taking the car first, there it is, nice big red circle around it. And I'm going to put some numbers in. So the car has a mass of 2,000 kilograms and it decelerates at 3 meters per second squared. That means for every second it decelerates a distance of 3 meters, so 3 meters per second squared. So F equals ma, or force equals mass times acceleration. So we do force equals 2,000 kilograms times 3 meters per second squared, which gives us a braking force of 6,000 newtons. So looking at the bus has a mass of 40,000 kilograms and it's going to decelerate at the same deceleration, 3 meters per second squared. But look at the mass. Look at the mass of the car is 2,000 kilograms. The mass of the bus is 40,000 kilograms. Again, we use the same equation, Isaac Newton's second law of motion. You've met this before. F equals ma, or force equals mass times acceleration. The mass is 40,000 kilograms, acceleration 3 meters per second squared. Multiply it and you get 120,000 newtons. So you can see that the car is only 6,000 newtons of force to stop it, whereas the bus is 20 times that. Okay, 20 times more force to stop it. So of course, because it needs 20 times the force to stop it compared to the car, it's going to go much, much further before it actually stops. So if you're in a classroom at the moment, this is a practical that you can do. I'm going to go through the practical, but I've got all the answers in a nice table of results for you. It's important that you're able to look at the numbers and make sense of the results. So this is what we would do in the classroom. We would attach a Newton meter to a block of wood, and there's the image up there. And we met the Newton meter in a previous lesson. You put the block and the Newton meter on a surface, maybe it's carpet, maybe it's wood, maybe it's your table, and then you very, very gently pull the block with the Newton meter. And just at the moment when that block just starts to move, you read the force reading on the Newton meter. So the idea here wouldn't be to pull the block all the way along and then read the number. You want to read the Newton meter reading just as that block is just starting to move. And that's the most important bit. And this is what your kind of table of results might look like. Name of object on the left, the mass of the object, so you put it on some scales and you can measure its mass. Surface 1, I've chosen a carpet, and surface 2, I've chosen smooth wood. And then, of course, we always write a little conclusion to try to describe or try to explain what happens. Okay, so that's what you would do. So here are my results here. I've done this previously. And the block of wood on the surface 1, on the carpet, 2.4 newtons to make it just move. And on the smooth wood, it was 1.2 newtons. Okay, so that's actually halved. It's half the force needed to move it when it's on the smooth wood. And in fact, that pattern repeated all the way through. And you can see on the carpet, the forces required to move the objects are much higher than what they are on with just using the smooth wood. So can you now copy down that table of results with all the numbers into your book? So pause the video now, please. Right, I'm going to carry on going. Okay, so here are your tasks now then. So write down a conclusion. Start with, I found that. Okay, so I've kind of helped you and I've just described kind of what my results show. So write down a conclusion underneath the table of results. And here are some questions. How could you increase friction on a surface? So what could you do to the surface to make there have more friction? 2, same question, but how could you decrease the friction? So how could you reduce the friction on that surface? 3, when you hold a bottle, your hand applies a force to the bottle. So is friction useful in this scenario? So your answer is going to be the yes or no. And number 4, when you go ice skating and the ice is really rough, it's really hard to skate. So is friction useful in this scenario? And your answer is going to be yes or no. So can you pause the video and answer these questions, please? Okay, let's go through the answers. So, conclusion. The rougher the surface or the more massive the object, the more force required to make it move. Okay, so when you had a rougher surface, or the carpet, you needed more force to move it. And also the more massive the object, the more force required to move it. I wonder if you got the second conclusion there, because I didn't write that in the table before. So hopefully you've thought about it, you've managed to add that one in. If you haven't, don't worry, just add it in now. And then the task 2 questions. How could you increase friction on a surface? You just make it rougher. You can get some like a knife or a pair of scissors, and you could really score up a piece of wood. If you have a carpet, you can brush it really, really heavily, and you can make it much, much rougher. How could you decrease friction on a surface? You can add oil to something, or you could lubricate it, which is a much better word. It just means to oil something, or you can put butter onto a surface, and that would decrease the friction. If you've got an old-fashioned desk and it's got the drawers in it, and you get the drawers and you pull them out and they're very, very stiff, you can actually get a pencil, just like a normal HB pencil, and colour in the top of the drawer, and it causes it to be lubricated in the same way, reduces the friction, so the drawer can go in and out much, much better. So it's a really, really useful tip. Number 3, friction definitely is useful, because if friction wasn't useful, then the bottle wouldn't be held in your hand. So of course you want to hold the bottle, so friction is useful. And number 4, the idea of ice skating is to have the least amount of friction as possible. You want to skate and go as far as you can. So in this scenario, friction is not useful, because the whole idea of skating on ice is to reduce the friction so that you can go faster and further. How did you do? Okay, as always, we've got the last tasks to do. So task 1, define the terms friction and braking force. Okay, hopefully you've got these in your book already. If not, just add them in now. Task 2, think about the park again. Write 3 sentences explaining where friction is, how it occurs, and whether it's useful or not. So we've discussed the first 2 parts of that. So it's your opportunity here to discuss whether it's useful or not. There's 2 super speedy worksheets. Okay, they are quick. They should take you no more than about 5 minutes to complete both. And they're found on the frog page in the activity section. Task 4, explain why it's safer for a tractor to drive at 10 miles an hour rather than 30 miles per hour. So look back at the 4 marker question you did earlier on and see if you can apply that knowledge to this question. And then task 5, as always, is the physics postcard. So just summarise your work using the Cornell method there. Okay, don't forget to email your teacher all of your work from today's lesson. If you have any questions at all, ping them an email, and I'm sure that they will want to help you. All right, take care everybody, and be safe.